Okay, Assalamualaikum warahmatullahi wabarakatuh. Can you listen?
Waalaikumsalam. Yes.
Can you listen?
Waalaikumsalam,
Clear.
madam. Yes, madam. Clear, madam.
Okay. So for today's session, we are going to analyze frame, indeterminate frame using force method or flexibility method. Okay, flexibility method. So we have 3 in class right now, only 3. So the rest join online. Okay, we are in seminar room level 6, yeah, level 6 in front of my room actually, seminar room level 6. Okay, so we are going to analyze this frame. So by looking at this frame has A, B, and C. A is fixed. A is fixed. B, rigid joint. C is roller. Okay, C is roller. Okay, determine reaction. Determine reaction. Of course, when we have indeterminate frame, we will analyze unknown reaction using what we call as flexibility method, because we have more than 3 unknown reaction, and in this case there are 4. Okay, actually we can just change this from single DOI to double DOI to 2 DOI if we change the roller support to pin support. Okay, doesn't matter. We focus on this one first. This is an indeterminate frame to the first degree of indeterminacy. Okay, we will analyze in indeterminate frame. We will calculate reaction, unknown reaction. There are 4 unknown reaction. And always remember that only 3. Okay, only 3 cannot be solved using equilibrium equation. So we have one redundant. Redundant is the problem. So we have to solve redundant using compatibility equation. And compatibility equation is actually based on displacement at redundant position. So step will be similar with beam analysis. Okay, and for displacement formula also, we will have to integrate moment equation, 2 moment equation. Okay, so we focus on the first question in this. Okay, first question. Here is the first question. Reaction at the support is the first question. So we focus on the first question first. Reaction at support. Draw axial force, bending moment, shear force, bending moment diagram using virtual work method. We calculate deflection. So this will be question number 3. This will be question number 2. Okay, anyway, we will focus on the first question. Okay, determine reaction at the support. So we have fixed at A, 1, 2, and 3. And we have roller at C. We have AY, we have AX, MA, and CY. There are 4 unknown reactions. So 4 unknown reactions including AY, AX, MA, and CY. Okay, CY. Okay, so always begin with N in mind. Always see what is the outcome, what is the goal. So the goal is to calculate all the reaction, and in order to do that, we have to calculate redundant. So redundant we get from compatibility equation. Compatibility equation we want moment equation. From moment equation we want reaction. So reaction for 2 system. We will have primary system and redundant system. One redundant, we have 2 system to analyze. One redundant, we have 2 system, because we will analyze primary system plus redundant system, 2 system. Okay, so we will start with Okay, DOI is equal to 4 minus 3. 4, it is 4 minus 3. This is equal to 1. So let's say we choose moment at A as redundant. So choose MA. Choose MA. As the redundant means that R equal to MA. MA. How many redundant? R1 redundant, right? So get familiar with numbering, yeah. R1 for redundant 1. Because when we have 2 redundant, we will have R1 and R2. R1 for redundant 1, R2 for redundant 2. In this case, we only have 1 redundant. So we have, we can write R and we can also write R1. Get familiar with numbering because after this, we will deal with all with numbering. So we have R1. So now, instead of using symbol A as the redundant position, we will use 1. So from this, we will write the compatibility equation. Okay, compatibility equation, the standard form of compatibility equation. Remember, this is moment. So moment, we have to calculate rotation. For moment, we have to calculate rotation. A, we change to 1. Because we want to use numbering right now. A, we change to 1. We can use A, of course, but we can also use 1. Okay, so 1 knot. This is displacement. Displacement at position of the redundant, position 1, position A tu. Okay, plus with F11. Bila kita pakai 1 knot, dia akan follow F11. If we use theta A knot, it will be FAA. This time we use theta 1 knot, it will be F11. F2 akan represent rotation. F ni flexibility coefficient. So F ni compulsory kat sini lah. In the equation, in the compatibility equation, we always have F. Okay, so F11 because we use theta 1 knot. If we use theta A knot, it is FAA. Okay, so and F cannot stand alone. We have to times with redundant. It is actually R1 here, but we change to MA. Okay, we put the redundant name directly. Okay, so this is equal to 0. This is equal to 0 in actual system. When there is fixed support, there is no rotation. Original is fixed support. So in fixed support, there is no rotation. That is why it is equal to 0. Okay, and this 0, this displacement in actual structure will change to value whenever in actual system there is a support settlement or support displacement. Okay, yang tu kalau ada effect support settlement, support displacement, okay, yang tu akan mengubah nilai 0 in actual structure jadi value. If there is support settlement given in the question. If not given in the question, it will always equal to 0 because fixed support theta is equal to 0. Okay, so this is the compatibility equation. And by looking at this, there are 2 displacement. It is theta. It is theta 1 knot equal to, we integrate, because this is frame, we integrate moment equation. So 1 over EI integrate, okay, from 0 to L. we will have two moment equation dx. Okay, we will have two moment equation two moment equation. We follow the notation. So now it is 1 knot. So here also 1 and knot. Dia macam 0, 1, 2, 3 macam tu. Okay, and kosong tu is always for primary. Okay, so M1, M knot. M1, M knot. Okay, and we have another displacement. Another displacement, it is F11, F11, and this is equal to 1 over EI. 1 over EI L. So this is M1 square. Instead of MA kan, MA. Kalau kita nak tulis in terms of A to A position, it will be theta A naught plus FAA kan. Times MA equal to 0. So theta will be theta A naught. Theta A naught and MA M naught. FAA become MA square dx. So this time because we use F11, M will be M1 square. M1 square. Square. Maksudnya boleh isi tapi dia hilang. Sekejap. M1 to M1 M1 square dx. So what is M1? What is M0? Always start dengan not because not is 0. So M0 tu is, what is M0? M0, it is the moment equation in primary frame. In primary frame. What is M1? What is M1? M1 is the moment equation in redundant apa? MA applied. Redundant MA applied. Redundant MA applied. So we know that we have two systems. One is primary system. Another one is redundant MA applied. Okay, these are the two systems. Okay, these are the two systems that we have to analyze. Two systems that we have to analyze. Okay. Okay, do you have any question? We have two systems. Remember the characteristic of primary frame. Primary frame is a determinate frame. Remove redundant. Remain external loading. Remain external loading. Primary frame. Redundant system. Redundant MA applied. The same type of frame means that whatever frame that we have in primary frame, redundant frame also same. The difference is only due to loading. So remove all loading. Okay, we have to apply a unit moment in redundant MA applied. That's all. Okay, so we have to analyze this. Okay, sini UDL. We have point load. Point load. Okay, we have, okay, fix after removing moment become pin. Become pin, so we have AY. Yeah. And sini okay. Okay, 8 kilonewton per meter along 9 meter length. This is 8. This is 8, 8, 9 meter, 20 kilonewton at the center. 3 meter, 3 meter. So this is 3 meter, 3 meter, 20 kan? 20 kilonewton. Okay, so this is primary. So this is primary frame. Primary frame. So we have another one, redundant frame. Okay, redundant frame. So in redundant frame, remove all external loading. Remove all external loading. Okay, apply a unit moment. A unit moment. Okay. A, B, C. Point load to, we have to put another joint, another point, D. Okay, and remain D to in redundant system. So it will be A, B, C, D. Okay, so everyone please calculate reaction for these two determinate frame. Okay, so we have two systems because we want to have two moment equation. Two moment equation, one for primary frame and one for redundant frame, redundant MA applied. Okay, so please calculate reaction. Please calculate reaction in primary. So in primary frame, we will have M naught, and in redundant frame, we have M1. In redundant frame, we have M1. Okay, kena konsisten. Kalau you pakai simbol 1, pakai 1 sampai habis. Kalau you nak pakai simbol A, MA, pakai A tu sampai habis. Jangan mix. Okay, so we have M0 for primary frame. We have M1 for redundant frame. Okay, so please calculate for me reaction in both primary frame and redundant frame. Okay. Dah ke? Dapat jawapan? Ada yang dapat jawapan tak?
Saya dapat, Madam.
Dah dapat dah, okey. Apa jawapan dia? For primary primary frame dulu.
Okey. CY saya dapat 42.67.
Sama tak? Okey.
CY.
CY right?
Betul.
Okey.
Lepas tu AY saya dapat 29.33.
29.33. Okey lagi?
AX saya dapat 20.
Okey, so ini 20. Okay. For redundant system,
Redundant CY saya dapat 0.111.
okay. So AY will be negative.
Ya.
AX 0.
Hmm.
Okay, like this. Okay. Okay, now we have done calculating reaction in both primary frame and redundant frame. Okay, next we will write the moment equation. How many cutting section? How many cutting section? 3. 1, 3. It must be 3 cutting section.
Oh yeah, three. Sorry.
Because of point load, 3 cutting section. Same goes to redundant. 3 cutting section. Okay. So for AB, the shortest, the easiest section start from when origin start from A. Okay, it's when origin start from A. So moment is counter clockwise. Okay, for C, for CD, always choose the shortest, the shortest section. So for CD, we choose C as origin. When C as origin, so the moment is clockwise. Okay, and for for DB, we can choose C as origin. We can choose D as origin, but remember the tips that I have mentioned in last session. Okay, so if you want to choose C as origin for DB, okay, the limit will start from will be 3 to 6. Okay, but if origin to for DB, bila origin to either D or B, you can always have limit from 0. Okay, so it's up to you. You want to choose which one as origin, but both will give us moment in clockwise direction because the origin position. Okay, so we have 3 cutting section. So we have to draw the same section, the same moment direction in redundant system. So we have to apply the same. Okay, so now please write the moment equation. Okay, write the moment equation. Okay, class. Have you got the answer? M naught for primary system. Section number 1, AB, origin at A, limit from 0 to 9. What is the equation?
Mx equal to 29.33x minus 4x squared. 4x squared, isn't it?
Again, M equal to?
29.33x minus 4x squared.
Minus?
4x squared.
You get the same? Ni UDL ada 4x squared. Or
Dia minus kan doktor kan?
minus eh?
Minus.
Okay. Minus. 29.33x minus 4x squared. Okay. Okay. What about M naught for member DC? Member DC, origin C. Zero, right? Zero. BD, moment equation for BD, origin D. Moment equation.
20x.
20x. It is 20x lah. Okay, 20x. Dapat 20x? 20x. Cos dia macam ni. Itu kalau origin dia, depend on origin. Equation will depend on origin. If your origin start from C, memang kena tolak 3 tu. So dia ikut origin macam ni kan section, the section. Sini 20 kan. So this is moment, this is M naught. If origin start from C, memang yang ni jadi X. Ini X kan, yang ni X 3 minus X kan. X minus 3. If origin start from C. But if origin start from D. If origin start from D, dia macam ni. Kalau origin start from D, sini 20. Sini D kan. Origin start from D means X. kat sini. So yang ni origin D. Ini origin C. Okay. Tapi limit different lah. Limit different. Origin D limit dia 0 to 3. Origin C limit is 3 to 6. 3 to 6. Careful ya when you write moment equation. That's why saya bagi tip last session saya bagi tips when you want to write moment equation. Actually paling senang origin ambil daripada kalau AB, A atau B dia memang akan start from 0. Kalau CB, either B or C origin dia memang akan start from 0. Tapi kalau nak cari for example nak cari equation BC tapi origin dia bukan B bukan C. So dia takkan start from 0. Okay? So you kena pilih. And dia kena, bila you pilih tu origin dengan limit dengan diagram ni, dia mesti tally. Jangan letak origin lain. Limit guna origin lain pun pula kan. Lepas tu section draw lain. So dia akan salah lah. So make sure tiga-tiga ni tally. Within diagram, origin tu akan tunjuk kat mana kita punya X. Kan origin kan. Lepas tu limit. Sebab in this case dia kan dekat X tu, dekat origin tu X dia 0. Dia punya konsep moment equation dekat sini. Kalau you choose C as origin, dekat C ni X dia 0. Tapi kita nak write equation for D to B kat atas ni. Ni B. We want to write equation between D and B. Between D and B, X dekat D is not 0. X dekat D is 3. X dekat B is 6. That's why limit dia jadi 3 to 6. Daripada bawah. Okay. So when we choose D as origin, X ni 0. Dekat D X 0, C kat atas ni. Kan? So dekat C, X ni jadi 3. That's why dia jadi 0 to 3. Ya, boleh pilih nak yang mana satu. Tapi kena faham the whole lah, tak boleh mix. Okay? Dan for me saya nampak yang lagi senang adalah dan takkan confuse adalah bila kita pilih origin. Origin tu kalau B dengan D, B atau D jadi origin. Kan? Kalau macam ni B dengan D, tapi C origin ni kan C tu bukan B bukan D. Dan X tu akan start from origin yang kita pilih tu. Okay? Yang online faham ke? So what should we get? It is negative or positive? It is negative 20x ya?
Negative.
Yeah, it is negative 20x. It is negative 20.
Doktor, tapi kita kan potong di antara dua section tu kan?
Ya.
Kalau if kita potong antara dua section tu and kita letak B ke D as a origin, kita tak ambil daripada A ke kita ambil daripada section tu juga?
Kita ambil daripada A, dia kan kita boleh pilih A as origin, tapi kalau you nak pilih A as origin section dia jadi macam ni. Allah.
Dia akan bersambung lah kan?
Dia jadi macam ni.
Okay.
Moment akan jadi the other direction. So which one is the easiest?
Yang tadilah yang D lagi.
So that's why kita ambil yang D as origin. Okay?
Okay, dah
So
clear.
always choose the easiest or the shortest. Okay, so now move to redundant diagram. Okay, what is the first moment equation for section AB? This is M1 ya. This is M1. What is the moment equation? Okay, what is the moment equation? It is 1 minus
1 minus 0.111x.
Yes, it is 1 minus 0.111x. It is 1 minus 0.111x. Okay, next equation. 0 juga yang last tu. D to B also 0. Kan? Both are 0, right?
Yeah, madam.
Okay. So we get 0, 0. Okay, now after this, so now we have all the moment equation. So what we need to do now is to substitute the moment equation into displacement formula. So we have two displacement. We have two displacement, theta 1 naught and F11. Okay, theta 1 naught and F11. Okay, so we will calculate the value. It is 1 over EI. EI constant. Length for AB is 0 to 9. 0 to 9. M1, M0. M1 is yang ni. Kali dengan M0. This is M0, right? M0. Okay, only this, right? Because the rest times with 0, right? So what is the answer?
One 153.02, isn't it?
Over EI. Yes, 153.02. Positive, yeah? 153.02 over EI. Okay? From 0 to L, from 0 to 9. From 0 to 9. M1, this one. square.
Three point zero zero
3.003.
zero zero.
3.003.
3.003 over EI. Okay. So these are the two displacement. One in the primary system, one in the redundant system. Theta 10 and F11. Okay. So we substitute this into the compatibility equation. So compatibility equation. And 3.003. Okay, so this is the compatibility equation. So we solve this. So we get MA negatif lah kan? Negatif. One, 5.3.02. It is equal to negative
50.956 or 96.
956.
6.
9556. Okay, kilo Newton meter. Okay. Okay, start ni by imagine dulu apa kita punya goal. Okay, imagine dulu apa punya final outcome, objective dia. The objective is to calculate all reaction. There are 4 unknown reaction, and only 3 can be solved using equilibrium equation. So 1 is redundant. So solve redundant using compatibility equation. Inside compatibility equation are displacement from primary system and redundant system. So inside the formula to calculate displacement are moment equation. Okay, moment equation. So there are 2 moment equation. One is M0, one is M1. So this M0 and M1 come from 2 system, primary system and redundant system. And in order to write moment equation, we must have reaction. Okay. So semua yang kita buat ada reason lah. Ada reason. Because kalau kita tak tengok from kita punya goal, kita akan hafal lah nombor 1 buat apa, nombor 2 buat apa, nombor 3 buat apa kan. Tiba-tiba sampai separuh jalan kita lupa apa nak buat. Okay, that is why the importance of knowing the objective. In the first side tu, mesti tahu apa kita punya objektif. Okay, and then kita tengok tangga-tangga nak sampai objektif tu kan. What is the next step? What is the next step? Okay, kita buat ni because of this. Kita buat ni because of this. Kita buat. Semua ada reason. Kenapa kita buat. Tak adalah kita nak buat benda yang tak ada kaitan. Okay, sebab kalau kita remember, kita mungkin akan lupa dan kita akan buat benda yang tak ada kaitan pun dengan apa yang soalan minta. Okay, so this is redundant. Redundant can be actually redundant. We can calculate remaining reaction. Dah dapat redundant kan? Dah dapat redundant bukan the end of analysis sebab kita kena completekan 4 unknown reaction. Now we only have 1. So we have to continue to calculate remaining 3. And remaining 3 can be determined by either using equilibrium equation or using principle of superposition. And if we calculate remaining reaction using principle of superposition, it is easier than we calculate reaction using equilibrium equation. Okay, so kita continue to calculate remaining reaction using principle of superposition. Remember the general equation. Okay, remember the general equations from principle of superposition. From principle of superposition, where general equation, okay, general equation based on principle of superposition, it is actual frame. This one is frame, so this is actual frame equal to primary frame plus redundant frame, and it is redundant MA applied. Redundant MA applied. MA applied. And we have three. AY, AX, and CY, right? Three remaining. We want to calculate AY. And then, okay, continue dulu yang ni. Okay, AY that we want to calculate is AY in actual frame. AY in actual frame. And remember, I said previously, in redundant system, all in redundant system tu dia bukan stand alone. Dia datang dari 1 times MA. 1 times MA. Sebab tu FAA tadi, F11 tu is F11 kali MA. So not only F reaction in redundant system also kena kali dengan redundant. It cannot stand alone. Okay, so in primary frame, AY for primary frame is 29.33. Okay, 29.33. So it is 29.33 plus negative 0.111. Okay, it is negative 0.111. Cannot stand alone. We must times back with redundant. Okay, kali dengan MA. So sini kita letak MA dulu. Okay, we must times with MA. Okay, we must times with MA. So jadilah yang ni equal to MA kita negative 50.956. 50.956. So this is equal to
.986.
positive 4.986.
34, Doctor.
34. 34. 34.986 ya. Betul-betul. 34.986 kilonewton. Okay. So for AY and CY also same. AX twenty plus ada ke? 0 kan? So this one is 0. Okay, 0. So it will remain 0 lah. 0 pula 20 lah kan? So it become 20. Okay. CY. CY 40 berapa tadi? 42.67 plus kan? Plus. 42 kan 22. 42 42. So this is 42.67 plus apa 0.111? Do you get?
$37.014.
37, yes, 37.014. 0.014 kilonewton. So when we use principle of superposition to calculate remaining reaction, okay, number one, it much more easier than using equilibrium equation. Kita boleh skip mistake juga kat sini kan, sebab this is just simple mathematical calculation, and we can also do checking using equilibrium equation. Tapi tak compulsory lah. Kalau you just nak check jawapan, you just put all into the actual frame and then using equilibrium equation, just checking whether you get 0 or not. Total moment is equal to 0. Total Fy is equal to 0. Total Fx is equal to 0. Okay. So this is flexibility method. Okay. How we calculate unknown reaction for unknown reaction using flexibility method. Okay. So start with kita kena tengok dulu apa dia punya objektif. Kita nak calculate all 4 unknown reaction. Okay. All 4 unknown reaction, and then so all step yang kita buat tu semua untuk achieve kita punya objektif. Okay. So this is for one redundant. Okay. This is moment. Okay. So ni moment. Ni bukan moment, ni frame, analysis of frame, one redundant. So sebenarnya sama if we have one redundant, we have one equation. If we have, for example, two redundant, we have two equation. And two equation in standard format, we have equation in matrix form, remember? Equation in matrix form. Okay. So yang ni clear?
Clear that.
Okay. Clear. Dia jadi pendek, quite pendek lah, quite short dia punya solution because one redundant, because when we have two redundant, we have 6 displacement. Okay, we have 6 displacement. And normally walaupun ada 6 displacement, yang paling susah tu cuma pada primary system. Because in primary system tu ada banyak loading kan. Due to redundant ni due to a unit value only. So kalau kita nak extend yang ni, kita add another redundant, kita boleh continue lah, and we can have we will have different moment lah, different reaction value. Okay, so this question we can continue. Okay, let's say kita just continue lah. Kita just continue. Consider. Okay, I just continue this. Now, let's say C is pin, eh? Let's say support C is pin. Just now roller, kan? Now pin become pin. So when it become pin, DOI equal to 2. DOI equal to 2. Remember, for 2 redundant, we have 3 system. 2 redundant, we have 3 system. So, and 2 redundant, we have 3 possible primary system. Okay, for 2 redundant, we will have 3 possible primary frame. Okay, 3 possible primary frame. 3 possible primary frame is number 1, possibility number 1 is when we remain fixed. We remove pin. Pin ni we remove. Jadi ada UDL tadi and point load. So this will be the first possible primary frame. Because in one determinate frame, we must have 3 unknown reaction, kan? Okay, this is possibility number 1. We can have possibility number 2, remain external loading. Primary frame, remain external loading. We want to remove 1 from A, 1 from C. Remove 1 from A, it become pin. Remove 1 from pin, it become roller. Okay, this is the second possibility. Okay, possible primary frame. Okay, yang ni we remove CX, CY. Yang ni we remove MA and CX. Okay, possible primary frame. And we have third possibility. Okay, the third possibility is when we remove 2 from A, we remain pin at C. Remain external loading. We remove 2 from fixed. We remove 2 from fixed. The redundant that we remove are MA and C. AX. So we can choose anyone. We can choose any option that we want. Okay. But normally in examination, redundant will be given. So you just need to follow redundant that have been given in the question. Okay. Kalau kita nak continue yang tadi tu, kan? Ada soalan? Kalau kita nak continue yang tadi, since we have redundant MA applied, kan? Kita boleh pilih either 2 or 3 lah to continue. Kan? Kita nak pilih yang mana? You nak kita buat yang mana ni? 2 or 3?
3.
3 lagi senang.
Kalau 3 kena buat balik. Sebab yang atas tadi kan kita pin dekat A, kan? Kita just nak continue yang atas tadi. So kita ambil 2 ya. Okay, kita take option 2 Take option 2. Okay, take option 2. Okay, so we have 2 redundant MA and redundant CX. 2 redundant we have We have R1. We have R1 MA. MA. Okay, and R2 CX, CX. 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 So having this, we will have compatibility equation. Okay, compatibility equation in matrix form. It is actually two simultaneous equation we transform into matrix form. So we start right from the primary system. Primary system. Okay. Moment is the first redundant. So it must be theta lah kat sini. But moment is the first redundant. Second redundant is CX. So second redundant is delta. Okay. So first redundant means 10. 10. Okay. Second redundant means 20. Okay. And we have to plus with 2x2 flexibility matrix. 2x2 flexibility matrix. 2x2 flexibility matrix. So all is F. Okay. All are F. So we just follow the metric characteristic for 2x2. Position dia 1, 1, 1, 2, 2, 1, 2, 2. 1, 1, 1, 2, 2, 1, 2, 2. Okay. Times with 2 redundant. Times with 2 redundant. First redundant, MA. Second redundant, CX. Okay. And this is equal to 0 unless if it is support settlement. It has support settlement. Actual equal to 0 unless ada support settlement given in the question. Okay, so this is the compatibility equation. So we have from this we know that ada 3 label dalam ni, 0, 1 and 2. 0, 1 and 2. It means that we will have to calculate moment equation from 3 system. Okay, we must have M naught. Okay, M naught from primary frame. Okay, second one, we will have to write M1 from redundant. Redundant number 1. Redundant number 1 is redundant MA applied. Redundant MA applied. And we have M2. We have M2. We have M2. Okay, this one from tengoklah 2 kita apa? CX kan? So from redundant CX apply. CX apply. Okay. So we want to complete the table, right? The table must have member origin, limit. So now we will have 3M. Now we have 3M, M naught. And M2. 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 We have 3 section. Okay. So ni sama macam yang table tadi tu. Kan kita dah kira separuh tadi kan. Okay. Dia semua sama. So boleh ambil balik semua ni. Alamak, dia kena ganti satu-satu. Tak apa, tak apa. AB, BD, DC. DC, origin A, origin D, origin C, limit 0 to 9, 0 to 3, 0 to 3. Okay. Allah. Nak copy, paste. Ini 0. Sini pun 0, sini pun 0. Okay. Okay, now apa yang tak ada kat sini? M2. 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 Kita balik. This is M2. M2 sini pin and roller. CX kan? CX is the redundant, right? 1. Okay. So calculate reaction in order to write moment equation. Calculate reaction in order to write the moment equation. Asing macam mana tu? Kita ambil balik diagram tu only. Loading tak ada kan? Diagram kita ni frame ABC, ABCD kan. Lepas tu dekat A ada pin. Sini ada pin. Sini ada, sini B kan. Sini D kan. Untuk original. This is a frame of redundant CX applied. This one is redundant CX applied. Tak boleh. Tak boleh. Kena asing. 2 redundant. Kena ada 2 redundant diagram. Okay. So that's why kalau 2 redundant, dia akan jadi 3 sistem. 3 sistem. Okay. So kira reaction in order to write moment equation. Kira reaction in order to write moment equation. So put moment equation as M2, put into the table, continue to calculate all 6 displacement. 6 displacement, dalam ni ada 6 displacement. 6 displacement, right? Ni. All 6 displacement, calculate. Okay, 6 displacement. Macam tadi jugalah, cuma yang ni ada 6 displacement. Okay, so from the notation that we use for the F symbol tu, kita dah tahulah. For example, yang ni F1, F11, M1 kali M1, M2, M2, M1, M2. Macam biasalah, kita just use notation in order to calculate the displacement. Okay, in order to calculate displacement. Okay. Yang online, faham tak ni?
Faham, madam.
Okay.
Faham dah.
Okay, so for the next 1 hour, kita akan tengok support settlement effect. Support settlement effect. So kita dah cover 1 redundant, 2 redundant, beam and frame. Okay, and lepas ni kita nak tengok macam mana kita nak solve problem when the structure has support settlement. Okay? So please complete
Baik,
this.
Doktor.
Okay, please complete this. Continue to calculate 6 displacement, actually 5 because F12, F21 is equivalent. Okay, and then substitute into the formula. So nanti, lastly, kan kita nak calculate remaining 3 reaction. Remaining 3 reaction, kalau untuk yang ni, dia akan jadi macam ni lah. For AY for example, dia akan ada satu, ni primary kan, plus kali dengan redundant 1 is MA, plus satu lagi AY, redundant 2 is CX tadi. Makan principle of superposition. Principle of superposition. Sebab kita ada 3 sistem kan. Kan ni primary, this is redundant 1, this is redundant 2. Redundant tak boleh stand alone. Mesti kali dengan redundant tu. Okay, dah dapat nanti MA and CX. Isi kat sini lah. Okay, so kita boleh continue to calculate remaining reaction using principle of superposition, which is easier than using equilibrium equation. Okay? Okay semua
Okay doktor, so jadi akan jadi F11, F21 lah kan?
Ya?
Untuk dia punya redundant tu, F11 dengan F21 betul tak?
Redundant.
Redundant.
Kena calculate semua. Okay, kena calculate. Tadi kita cuma calculate yang ni. Yang tadi kita cuma calculate yang ni. Yang tadi. Yang boleh ambil balik dan apply dalam yang ni kan. Now we have to continue to calculate delta 2 naught, F11, F12 dengan F22. Okay, so completekan 6 displacement, substitute and then solve macam biasalah using simultaneous equation. Okay?
Okay doktor, boleh.
Boleh? Kena completekan Kena completekan, nanti tak complete nanti lupa pula. Okay, so that's all for this session. InsyaAllah we will meet again in the next session. Thank you very much. We close this session with Tasbih Kifara and Surah Wa'as.
Thank you doktor. Jangan lupa attendance.
Okay.
Doktor ada nanti next session ada lagi ke kelas fizikal?
Next session hari Khamis
Khamis.
petang. Khamis petang insyaAllah. Tengok pada availability room ni.
Okay.
Tapi selalunya kalau
Sebab-
Khamis petang tu insyaAllah lah kot. Nanti hari Khamis baru kita update ya.
Okay, sebab saya nak cuba kelas physical pula.
Okay. Okay,
Okay.
please come.
Okay,
Please
thank you,
come.
Madam.
Okay. Okay, thank you.
Okay, thank you, Doctor. Thank you, Doctor.